Imagine standing on the deck of the most luxurious ship ever built. Around you, more than 2,000 people believe they are aboard the safest vessel in history. The crew is calm. The passengers are celebrating. The Atlantic Ocean is perfectly still. Then, less than 3 hours later, that same ship is gone forever. For more than a century, people have blamed the iceberg. But what if the iceberg wasn't the real reason the Titanic sank? What if a series of engineering decisions, each one reasonable on its own, combined into one of history's greatest disasters? Today, we're uncovering the engineering mistakes that turned the world's most advanced ocean liner into its most famous shipwreck. When RMS Titanic left Southampton on April 10, 1912, she represented the peak of human engineering. She was nearly 270 meters long, weighed over 46,000 tons, and contained technology unlike anything the world had ever seen. Thousands of workers had spent years constructing her at the Harland and Wolff shipyard in Belfast. Newspapers described her as practically unsinkable. While the company never officially claimed she could never sink, the public quickly embraced that belief. Everything about Titanic was designed to impress. She had electric elevators, luxurious cabins, Turkish baths, a swimming pool, grand staircases, and one of the largest steam-powered propulsion systems ever installed on a passenger ship. Wealthy travelers saw her as a floating palace. Even third-class accommodations were better than first-class cabins on many other ships of the time. Beneath all the luxury was an engineering masterpiece. Titanic's designers knew that ships could collide with other vessels or strike rocks. To protect against flooding, they divided the hull into 16 major watertight compartments separated by steel bulkheads. Massive watertight doors could close automatically if water entered the ship. It was one of the most advanced safety systems ever created. This system gave everyone confidence. Engineers calculated that the ship could remain afloat even if several compartments flooded. That was extraordinary by the standards of the early 20th century. But hidden inside this brilliant design was a limitation that few people fully appreciated. The watertight bulkheads did not extend all the way to the upper decks. Instead, many stopped several decks below the top of the ship. Under normal circumstances, this wasn't considered a problem. Engineers believed flooding would remain isolated because no realistic accident would damage too many compartments at once. That assumption would prove catastrophic. As Titanic crossed the North Atlantic, wireless operators received multiple warnings about drifting ice. Other ships reported dangerous ice fields directly ahead of Titanic's planned route. Some messages reached the bridge, while others were delayed or never given the attention they deserved. The sea was unusually calm that night. Ironically, calm water made icebergs harder to detect because there were no waves breaking against their sides. At 11:40 p.m. on April 14th, lookouts finally spotted an iceberg. They had less than 40 seconds to react. First Officer William Murdoch immediately ordered the ship to turn while attempting to reverse the engines. The maneuver nearly worked. Titanic did not crash head-on. Instead, the iceberg scraped along the starboard side for only a few seconds. To passengers, the collision felt surprisingly minor. Some barely noticed it. Yet below the waterline, the damage was devastating. Contrary to popular belief, the iceberg did not rip a gigantic hole through the hull. Modern studies suggest several narrow openings appeared across multiple sections of the ship. Individually, many of these openings were small. Together, they allowed seawater to enter 6 forward compartments simultaneously. That number mattered. Titanic had been designed to survive flooding in 4 compartments, and under certain conditions possibly 5, but not 6. Water immediately began filling the front compartments. As they became heavier, the bow slowly sank lower into the ocean. That changed everything. Remember those watertight bulkheads? Because they didn't reach high enough, the lowering bow allowed water to spill over the top of each bulkhead into the next compartment. like water overflowing from one bathtub into another. The safety system that looked revolutionary on paper had a fatal weakness. Instead of containing the flooding, gravity allowed the ocean to move steadily deeper into the ship. At this moment, Titanic's chief designer, Thomas Andrews, inspected the damage personally. After examining the flooded compartments, he reached a heartbreaking conclusion. The ship had roughly 2 hours to live. It wasn't panic that followed, it was disbelief. Passengers continued drinking coffee, reading books, and talking in warm lounges, while engineers below fought a battle they already knew they could not win. The greatest engineering project of its generation had already lost. As engineers rushed below deck, they immediately realized something was terribly wrong. Water was pouring into the forward compartments faster than the pumps could remove it. Titanic carried powerful steam-driven pumps, among the best available in 1912, but they had been designed to deal with ordinary leaks, not thousands of tons of seawater entering every hour. The pumps were never the solution. They were buying minutes. Chief designer Thomas Andrews carefully measured how quickly each compartment was flooding. The calculations were devastating. Every minute, the bow settled lower into the Atlantic. Every centimeter allowed even more water to spill over the tops of the bulkheads into the next compartment. The ship wasn't simply filling with water. It was sinking because its own design allowed the flooding to spread. But that wasn't the only engineering problem. For decades, many historians believed the iceberg had sliced open a massive section of Titanic's hull. Modern investigations paint a very different picture. When scientists studied the wreck and examined original construction records, they found evidence that the hull had suffered a series of relatively small openings instead of one enormous tear. In total, the damaged area may have been only a few square meters. That raises an obvious question. How could such limited damage destroy the largest passenger ship on Earth? The answer lies in the materials used to build her. Titanic's steel was considered high quality for its time. Yet engineers in 1912 knew far less about how steel behaved in freezing temperatures than engineers do today. The North Atlantic that night was brutally cold. The water temperature was just below freezing. Modern laboratory tests on steel similar to Titanic's have shown that, under such conditions, it becomes significantly more brittle. Instead of bending under extreme force, it is more likely to crack. This doesn't mean the steel was poor. It means science had not yet fully understood how different temperatures affected large steel structures. Another weakness was hidden inside thousands of small metal fasteners holding the ship together: the rivets. More than 3 million rivets connected Titanic's steel plates. Most were made from steel, but in several areas of the bow, workers used wrought iron rivets because they were easier to install by hand in difficult locations. At first glance, that decision seemed harmless. But later investigations suggested some of these iron rivets contained higher amounts of slag, tiny impurities trapped inside the metal during manufacturing. Normally, they performed well. Under the violent impact with an iceberg, however, some engineers believe certain rivets may have failed earlier than stronger steel ones would have. Instead of keeping the steel plates tightly connected, several rivets may have popped loose, allowing seams between the plates to separate just enough for seawater to rush inside. Even tiny gaps were enough. At the pressure created by the ocean, every opening became a powerful stream. Still, materials alone did not sink Titanic. Human decisions also played a critical role. Despite repeated ice warnings throughout the day, Titanic continued traveling at nearly full speed, around 22 knots. Today, that seems reckless. But in 1912, it reflected common practice. Captains often maintained speed through ice regions because they believed experienced lookouts would spot hazards in time. Ocean liners also competed for prestige. Fast crossings attracted passengers, strengthened reputations, and demonstrated engineering excellence. No one wanted to arrive late. Captain Edward Smith was one of the most respected captains in the world. He had decades of experience and an outstanding safety record. There is no evidence that he intended to take unreasonable risks. He was following standards that many other captains considered normal. Unfortunately, those standards were based on assumptions that failed under the worst possible conditions. The sea was unusually calm. There was no moon. The iceberg blended almost perfectly into the darkness. By the time the lookout saw it, physics had already taken over. A ship the size of Titanic simply could not turn quickly enough. Ironically, some experts believe that if Titanic had struck the iceberg head-on instead of trying to avoid it, fewer compartments might have flooded. The damage would have been concentrated in the bow rather than spread across 6 compartments. Many people at the front of the ship would almost certainly have died instantly, but the ship itself might have remained afloat long enough for rescue ships to arrive. It is one of history's most tragic engineering what-ifs. No captain wants to ram an iceberg intentionally. Instinct says to turn. On almost every other ship, that instinct would have saved everyone. On Titanic, it created exactly the pattern of damage the designers had never expected. By 1 a.m., there was no longer any doubt. Titanic was dying. Yet many passengers still refused to believe it. The ship's lights were on. The engines had only recently stopped. The orchestra continued playing, and inside the warm dining rooms, everything still looked almost normal. That illusion would cost precious time. One of the most famous facts about Titanic is that she did not carry enough lifeboats for everyone on board. More than 2,200 passengers and crew were traveling that night, yet the ship had lifeboats for only about half of them. At first glance, this seems like the greatest engineering failure of all. Surprisingly, it wasn't. The number of lifeboats actually met, and even exceeded, the British safety regulations of the time. Those regulations were based largely on a ship's tonnage, not on the number of people it carried. When the rules were written years earlier, no one imagined passenger ships would become as enormous as Titanic. In other words, the regulations had failed to keep pace with engineering. White Star Line could have installed many more lifeboats. The large boat deck had enough room for additional boats. But company officials believed the existing number was sufficient under the law, and some worried that too many lifeboats would clutter the elegant appearance of the ship. The assumption was simple. A modern passenger liner was expected to stay afloat long enough for nearby ships to rescue everyone. Titanic proved that assumption wrong. Even worse, many of the first lifeboats left only partially filled. Some carried fewer than half the people they could safely hold. Crew members feared that overloaded boats might collapse while being lowered. Passengers were reluctant to leave a ship that still appeared stable. Valuable minutes disappeared, while empty seats floated away into the freezing darkness. Meanwhile, below the surface, the engineering battle had already been lost. The bow continued sinking deeper. Every compartment that flooded increased the weight pulling the front of the ship downward. As the angle became steeper, furniture slid across rooms. Glass shattered. Boilers broke free from their foundations. Thousands of tons of water surged through passageways that had never been designed to hold it. The enormous forces acting on the ship were unlike anything its designers had expected. Then came the final structural failure. As the bow disappeared beneath the surface, the stern rose high into the air. For a brief moment, Titanic balanced under impossible stress. One end was supported by the ocean. The other hung almost entirely above it. The hull had become a gigantic steel beam carrying its own weight. No passenger ship had ever been tested under conditions like these. Eventually, the stress exceeded the strength of the structure. The ship broke apart. For decades, many survivors believed Titanic had sunk in one piece. It wasn't until the wreck was discovered in 1985 that researchers confirmed the ship had split into 2 massive sections before reaching the ocean floor. The bow plunged downward first. The stern remained afloat for several minutes before filling completely with water and disappearing beneath the Atlantic. More than 1,500 people lost their lives, not because of a single mistake, but because many small engineering limitations, outdated regulations, environmental conditions, and human decisions combined into one catastrophic chain of events. The tragedy transformed shipbuilding forever. International safety laws were rewritten. Every passenger ship would now be required to carry enough lifeboats for everyone on board. Continuous radio watches became mandatory, so distress calls could never again be missed. Ice patrols began monitoring the North Atlantic, warning ships about dangerous icebergs before they entered busy shipping lanes. Engineers also changed how they designed watertight compartments, emergency systems, and damage calculations. Every major passenger ship built afterward benefited from lessons written in tragedy. More than a century later, Titanic remains one of the most studied engineering disasters in history. Not because engineers failed completely. In fact, Titanic represented some of the best engineering of its era. What doomed her was something far more dangerous: confidence. Confidence that the design was strong enough. Confidence that existing safety rules were sufficient. Confidence that experienced crews could always avoid disaster. NG